record a copy just in case the stream fucks up. Pop out chat.
Oh, real YouTube chat now.
Oh yeah, I just opened it in the window. Okay, OBS chat. This can be minimized.
So I can ban people.
You can ban people. Is the air too cold in here?
No, it
I
feels
should
good.
make it. There's no such thing as too cold. Okay. Thank you very much. Oh, so today there's the stream that I was doing the other day where I was trying to fix this board that was dead, not charging, no touch bar, and I got a quarter of the way through it, and Paul is going to now go through and fix what I screwed up. So, as usual. So, without further ado, say hello to Paul.
Hi, everybody. This one's not on either.
Actually, I think it is. It just it doesn't. The screen is broken. Actually, no. Oh, it is actually off. Okay.
Oh, there you go.
Flash cam's there.
That's good. Okay. So, yeah, as Lewis said, this is the one he was working on 2 days ago, I think. And Dan took a crack at trying to verify that everything was working with my test housing. And they found USB communication was not working. So let's look a little bit farther into where they were going. Let's see here. Sorry, usually all this stuff is taken care of before we start the stream. Okay, that looks right. So, hi. Some of you may know me from previous videos, such as Rossmann Group Cap Scam. I'm Paul S. from Rossmann Repair Group. So we have, you may know me from the Paul Q. So we have A1706 logic board. What number logic board is this? I think there's only one in the A1706. A1707S2. I think this 1706 only has one. This is an A2000923A. No, they do have two. So it was liquid damaged. The touch bar connector was really badly damaged. Lewis replaced the touch bar connector. He had a hard time with it. Everything looks fine with that. There's two pins that could use some more solder on it, but that's not that big of an issue. So if we take a look, so we start with initial function checks here. So I'm going to check every single one of the USB-C ports and make sure that they're accepting power. So we look at this one here. So we have 5 volts. We have 20 volts, we have 600 milliamps, so it's turning on with that one. So that's fine. Let's try this one here. 5 volts, 20 volts, 700 milliamps turning on. So now I have to, so there's, for the charging circuit, there's 2 paths. So this is a omnidirectional connector, or bidirectional connector. I'm not sure what the good term is for that. Because bidirectional means communication. Omnidirectional, I guess that works. You can plug it in that way, you can plug it in that way, you can plug it in that way. So there are 2 sets of data lines, one on the top, one on the bottom, to communicate with everything. So when we check things, we have to take the connector out, flip it upside down, plug it back in, and we have to check it again. And that should not have turned this on. Yeah, this thing should not be taking 5 volts. I don't know where this amp meter is from. I don't know why that just did that. That could be why they're seeing weird issues here. This amp meter is weird. I've never seen this one before. Okay, I'm going to have to go to stored.rossmanngroup.com. Wait, I got a bright one. Okay, hopefully this one works. So we know this one works, so let's try that. Okay, 5 volts. 20 volts. That's working. This is not working. Okay, so if I unplug this, turn it upside down, plug it back in. Now it turns on. 5 volts. 20 volts. 700 milliamps, turning on. So now I'm flipped over to the other side of this again. So we'll try this one. This one's working. 5 volts, 20 volts, and 700 milliamps. So this top one's working fully. This charge port's working fully. This charge port's only working on one half of it. So we have to remember it's the bottom one is only working on one half. We'll come back to that. Continue our function check first. We're going to go to the other side and do the exact same thing. Plug in here. 5 volts. 20 volts. 700 milliamps. Turning on. And try this one. Nothing. Okay, we'll unplug my charger. Flip it upside down. Plug it back in. Still nothing. Okay, so this top one here, I'm going top because I consider this the bottom of the board. So this one here, the one inboard to the board, this one's dead both ways. And this one is fine both ways. So before, on the other side of the board, it was the edge one is bad one way, and this one's good both ways. So, okay, so we have 2 bad CD communications or something going on with the CD3215s. So when we look at a CD3215, when we look at the pinouts and everything, you have on these pins here, we have power, we have ground, we have USB 2 communication, we have Thunderbolt communication, and we have something called CC1 and CC2. I'm not exactly sure. I think it stands for charger communication. Could be something else. I could be way off on that. I don't know. Never looked it up because it's a trivial detail. Don't really need to know. But you need to know that there's a CC1 and a CC2. One's on one side, one's on the other side. It's offset to one side. So like this one up over here would be CC1, and then on the other side, this one over here, it's like offset. This would be CC2. One of these, since only one side works, one of these could be shorted. So first thing, which one was it? It was this one, right? So that's not working. I'm going to flip the charger around. And that is working. Okay, so it's this bottom one is not working. So now we need to identify which CD3215 it is, because each port has its own CD3215. So we need to identify the bottom one here. Does it go to this one, or does it go to the one on the other side of the board? So we're going to open up our schematic and board view using Paul Daniels software. 1706, where are you? 1706, 923 board. Okay, let's bring that up on screen. So here's our board view. Let me put this in a direction like we're holding it. So yes, this is what we're seeing when I'm working on it. The CPU is right on top here, and this is the side that we're working on here. So this is the plug that the 2 charge ports hang out of, and we're working on the edge of the board here, the one that's towards the end here. This is the one that's giving us a hard time. So we have to find out this half of the connector, what does it connect to? Does it connect to this CD3215, or does it connect to the one on the other side of the board? So we'll click on some stuff here. Let's find this CC1. There's CC2, either one. Here's CC2. And that's coming right over here to this one. So we see we're on the same side of the board that the connector's on. We're working on the same side, CD3215. If we come up over here and look at the one on top, here's CC1 for the other one. So if you see it says USB-C XA CC1. We look over here, it's USB-C XB CC2. So the XA XB is the one connector or the other connector. So if we click on this one here, the XA, and you see that it turns into little blue dots here. The blue dots indicate that it's on the other side of the board. It's showing you that it's connected here, but the blue tells us it's on the other side of the board. So if I click my mouse wheel, I will flip the board over, and there it is. This is the other side of the board. So this is the one that's working fine. There's nothing wrong with this CD. But this is the one that we're having a hard time with. So let me find CC1 again, or CC2, and there it is. So CC1, CC2, they're right next to each other on the CDs. So CC1, CC2. One of these is bad. We could test it as bad, or we just know it's bad. Could be the CD that's bad. Could be one of these diodes or these capacitors. So let's do a couple quick checks, because it would be great. These are underfilled CDs. These are a real pain in the ass to work on. Let me bring up the microscope so you can see. These are underfilled. They have a black tar stuff that's filling underneath them. Real pain in the ass to work on. So it would be ideal if it's something external to the CD that's bad rather than the CD itself. That would be wonderful. Since I'm working on this board, I almost guarantee you it's going to be the CD, and we're going to be redoing underfilled CDs today. This is not balanced focus. Let me just fix the microscope camera. Okay, the microscope's not balancing to the view. That'll do, I guess. Okay, so when you look at go back to the schematic and board view, this is what we're looking at. This is what we see under the microscope. So we have the CD3215, and we have CC1, and this is CC2, and it goes to these four pieces right here. So we have a capacitor, and diode for both. So we're going to check to see if these capacitors are shorted to ground. So turn on the multimeter here. Multimeter's not turning on. Is it shift there? There you go. Okay, we have our multimeter readings. I'm switching to resistance readings. And there's the two capacitors, two diodes we're looking at. I'm going to put my black probe on ground, and we're going to probe this right here and see if this is shorted to ground. 108 ohms. That doesn't seem right. I think it's supposed to be a lot more than that. What's this? 4.62 mega ohms. That's 4.63 million ohms, versus this one is 105 ohms. So that's why the CD is working in one direction and not the other. It'll charge and communicate in one direction because this one is fine. There's nothing wrong with this line. For 3.8 million ohms, that's fine. This one here, 104, staying at 104. Now, a trick that I like to do too when testing for a short like this, I'll reverse my probe. So I have it like this, and they're going to pass each other, and the red is now going to go to ground, and the black on here, and I still get the exact same reading. So that's definitely a short. It's not like a diode or something like that you're going through in one direction or something like that. That's definitely a short because it's the exact same reading. So the first thing we're going to do is take this, both the capacitor and the diode off of this next to the CD here. So now this is kind of tricky because, where are my tweezers? Oh, there. This is kind of tricky because the CD's underfilled, and we don't want to overheat the CD and cause any disturbance to the solder underneath the CD. Because that will ruin the CD, even if it was good. If you see solder balls coming out from underneath the CD, that's no good. So we need just enough heat to get these off of here. So I don't adjust the heat on my station. I'd set it 500 degrees, 500 degrees C, and 120 liters of air per minute. So that's the full and full for this thing. I adjust my temperature based on distance to the board and how much I keep it on one spot. So the capacitor's free. I want that diode off of there too, though. Well, actually, with the capacitor free, we can test it. The diode's giving me a hard time. We could just test it now. It would be amazing if it's just the capacitor. So black probe on ground, red probe here. And we still have 138 ohms. Let's get that diode off of there too. That one moved so quickly, I wonder if it was already touched. If Lewis already messed with that one. That seems like it has leaded solder on there. So this must have had some liquid damage over here. Okay, the diode's off. I'll test again the same way. We still have 140 ohms to ground. Okay, so now we know it's definitely the CD. This CD has to come off. So, underfilled CD. Dealing with underfilled chips is a real pain in the ass. Step number 1. I take my device of gravity. This is a Omnivice, the HAKKO Omnivice. Really useful for all kinds of stuff. You could put small boards in here and hold them and work on them. It's very, very heavy. This thing is very deceiving how small it is, but it's just a solid chunk of steel. Nice and heavy. So this is just going to go rest on the board just to give my board some stability while I'm working on all of this. Because I'm going to be scraping on a lot of things and I don't want the board sliding around while I'm working on it. So I'm going to take a underfill cutting knife. So this is a curved blade, kind of X-Acto knife, but it's a curved blade with a little point on it. And we're just going to use this to cut the underfill around the chip a little bit. We're going to use some heat. I don't want solder melting heat. I don't want to melt any solder yet around here. I just want everything warmed up so that the underfill just gets cut through. Anywhere, especially that has components right next to it. I don't want to pull the components up when I pull up the CD. You don't want to scrape too hard. You don't want to damage the board too much. You scrape too hard, you're going to see lines in the solder masking on the board. Just all 4 sides. There you go. So now we cut all 4 sides. I'm going to add a little bit of flux so that the flux gets underneath it as I start to lift it. Another area you could get in trouble when working on this is that there's another underfilled CD right on the other side of the board from this. So that you can get in trouble with overheating this and wind up melting that one too and ruining it. I'm going to turn on the fume extractor because this is going to get a little smoky in here. What happens if the underfill melts? The underfill doesn't really melt. It doesn't melt in flow or anything like that. But it does get softer as you get it hot. So now again, I have my station at full and full. And I'm just going to get a corner. I got a somewhat clear area here. Just watch what components you're around over here as you get in here. I'm probably going to knock something off as I do this, but we'll just replace it as we go. I'm going to get one point of my tweezers underneath here and just start heating it up. And now as I'm heating it up, I'm looking at these resistors under the bottom. I'm looking at the fuse over here and stuff. I'm looking for that solder to start turning shiny. That tells me that things in the area are getting melted. And I got solder balls popping out. Now I could start lifting up on this. And there you go. Lift it up, it pops off, it's gone. So you can't put any pressure or lift up on it until you're sure everything is melted around here. Because if something is not melted, if one of these balls did not melt, and I start lifting up on it, I'm just going to rip the pad right off the board with the chip. You don't want to do that. It's a real pain in the ass to correct that and clean that up. So now I need to remove all the underfill that's left on the board here. Let's get a Q-tip in here first so we can see what we're working with. Just get some alcohol on a Q-tip. Clean up everything. I got some nasty solder blobs around. We'll correct all that as we go. I did push a little hard in the top here, and you could see how the solder mask got cut a little bit. Okay, we did lose a couple pads. There's a couple pads that did come up with this. So we're going to have to rebuild a couple pads. Sure should have been melted enough, but they came up anyway. Okay, so now we need to clean everything up. I'm going to take a micro pencil tip that I have that is kind of ruined. It doesn't hold solder anymore. And I'm going to use this old micro pencil tip to scrape away at all of the underfill, nice and light. Okay, so I got my micro pencil here. I'm going to use a little bit of flux on here. I'm just going to lightly scrape away at this underfill and pull the solder off of these pads. Nice and light. I don't want to put a lot of pressure on here, and I don't ever want to push in this direction. So you see the angle that I'm holding this at. So I have like a smooth ramp that's going down towards the board. So if I'm going to push on anything, I'm pushing it down into the board. If I were to start pushing this way with this tip, I can get underneath one of these pads and just lift it right off the board. Sometimes the pads are so weak it's unavoidable. These things come off all the time. Okay, let's see how bad of a situation we got ourselves in. We're going to look at the pads that are missing. So let's look at that top right corner first. We'll start from the top. So this one here. We'll go back to the schematic and board view. And that's this one here. That's only a ground. So we may be able to just ignore this one. We're going to have to check on the chip itself. So you see that there's a bunch of grounds here, and we're missing one ground pad. Shouldn't be a big problem, but here's the thing. I see people all the time in the forums and stuff like that, other technicians, that when you're missing a pin on a chip like this, and you say, oh, it's just a ground. Well, if you can completely prove to me that that ground is nothing more than ground, and it is the same as the ones next to it. When you look at this, it's ground. That's ground. That's ground. If that is the same pin as this, then you could leave it out. You don't have to put a new pad on here. But if you measure this to the other pins, and you don't have any connection from this to any one of these other pins here, you better put that back. Because this is showing you, like what we're seeing here, this is the connections on the board. We don't know what the actual connections are on the chip. This could be some floating data line that's on the chip, a data input or something like that. And if it's not tied to ground, this chip could act erratically. It can act crazy. So if it's connected to the other grounds, then you don't have to put it back. But if you ohm check this to other things, if you diode mode check this to other things, and it's not shorted to any of these other grounds, it's not connected, you better put that pad back. because you're going to have some weird erratic operations if this is some data pin that is supposed to be held to ground, and now you're not holding it to ground. So let's look at our next one. So this one, we can see right away that it has a trace running to it. That's for USB 2.0, because that's where this is going to. That's the USB 2.0 communication, I believe. So that one's going to have to be put back. And let's check this one here, too. You could see the trace coming here. That one needs to be put back. And is that one's still there? Okay. Some junk around it. Okay. So we have 2 that we definitely have to rebuild, and 1 that we might have to rebuild. Oh, what's this? Is this one missing? Yes, that one's missing too. Let's see what that is. Above the naturally missing one. That's this one. I2C UPC XB debug. Yes, we need that. So it's only being held to 3.3 volts, but that needs to be there. So yeah, we have 4 pads to rebuild. Yay. Okay, not an ideal situation. But while we're at it, should I do the other side? No, I should do this side first. Let's just go ahead and fix this up. Lewis's micro pencil does not look to be in good condition. Let's clean this up. Oh, a pro tip. Your micro pencil, when you want to change out these micro pencils, first off, this whole thing is hot. The whole thing is discolored. You can actually see it glowing as it heats up right there. This whole thing is ridiculously hot. So first, I have the dual station. Instead of turning it off or having it scream at me, I'm just going to lift the other station up, the other handle up. Oh, Lewis's other handle doesn't work. Okay, so that lifting up the other handle turns this off. And I'm going to slide my tweezers on this thing, because this is just a great wrench for this. Slide my tweezers on this, hold them down here, and I can pull my tip out. And the back of it should be cool enough to grab a hold of. That's an easy way to switch your tip. And then I'll take the other tip that's going in here, and this is cool so I can touch it, but as soon as you plug this in, you better let go of it quick, because these heat up really quick. So you line up the notch with the flat spot, plug it in, it beeps, hit the handle, and this should be warming up. Or the stand, the sleep stand. And that's hot. Let's clean this up and see if this is usable. Yeah, this tip's okay. It's upside down, though. That's a pain. Like, the wire wants to hold the tip in the exact opposite direction than I really want to hold it. Okay, so first thing we need to do is clean off. Let's see, which one are we going to work on first? Let's do the ground one. So we just need to get some copper. You can see the pogo, the through board via that connects to this. So this might be a little difficult to solder to because it is ground. So we get some solder on our micro pencil. Just try to get that little pogo pin to take solder. That pogo pin's probably not going to want to take solder. I might have to build a pad off the pad next to it. Clean it out some. Yeah, it just doesn't want to take solder because it's ground, and it's wicking all my heat away from this little iron. So what I'm going to do is preheat this with some hot air. Just come in with hot air. I'm going to preheat the area. I want the whole area to be warm because it's ground and it's going to dissipate pretty quickly. Just going to warm the whole area. I don't want to melt any solder really. I just want everything nice and hot. I want the area to retain the heat, so I'm doing a large area. Okay, I'm going to add some flux. And we're going to come back in with the micro pencil. And that little via should take some solder now. This tip might not be good enough. I'm expecting solder to stay at the very end of the tip, and it doesn't seem like it's going to. That's what wears out on these micro tips first, is the very pointy tip. And that's what I need solder on to get something on this. There we go. It took some solder. Okay. That is at least tinned. Let me get my... oh, here's an X-Acto. Okay. Let's work on this one here. Scrape off the solder mask. In that one too. There you go. Scrape that off. I'll scrape this one off. Oh, that big lump of solder just made me pull that off by hitting it. Oh, we'll just glue it back down. It didn't rip. Dab of flux. Little dab will do you. Some solder on that. Solder on that. That looks good. Okay, I'm gonna go get my micro tip. Permit me one moment. Okay, I am back. I grabbed my whole handle off of my station. Ooh. This thing is not very movable. Let's turn the station off. Get Lewis's handle out of here. And I'll plug my handle in. Lewis's tweezers don't seem to be working. Not sure why. Yeah, they're dead cold. Okay. Okay. So from here on out, this is just obnoxious solder work until we get to the next side. I guess let's start with the easiest one first. Where is... I'm going to be using some... What size does those have here? 44 gauge magnet wire. So this is enamel wire. It has an enamel coating on it. So it looks like it's copper, but it's a clear, kind of coppery colored coating that's on the copper wire. And I need some flux on here. This isn't going to work too well without flux. Just got it tacked on there so it'll stay. And we'll get a little dab of flux on here. Okay, so I need to just... There's something in my tweezers that won't let me touch this. I need to just get this soldered on here at one point. And then I'm going to make a loop with it and bring it back to that point, and then I'll solder them both together. So we're just going to make a circle the same size as the pad. Realize it's kind of difficult to see through all the flux. I'm going to hold it down. Hopefully that holds it, and we're going to solder right at the end there. There you go, that's one corrected pad. Then we'll just add green all around it and inside of it. And then once we harden the green solder mask, then we'll scrape it away on the top and reveal a nice pad. So that's the same thing we'll do for all of them. seems okay. This one's getting really close to the ball next to it, so this might be a bit of a pain. Okay, that kind of worked out. That should work. We'll reshape that after we get it out of the UC. Oh shit, am I off camera? I'm sorry. Okay, and then the last one, we might have to add a little bit of heat again to get solder to stick to that ground pin. And this one, since the pin's straight down the center of it, I'm going to be doing it a little different than the other ones. I just want this to connect to it. Oh, look, that soldered really well. Let's get a little bit of flux in there. It's making a point of solder. I don't want a point of solder. There we go. Nice flat glob. Perfect. Now I'll just leave a couple millimeters of wire off of that one. I'll cut it out here. There we go. Now I'm going to go dunk this in the ultrasonic cleaner, and then we can clean up and shape up everything, and we'll do it in the green. So I'll be right back. Couldn't be more difficult.
Hey, what is this portion of? Does this have underfilled CD3015s?
Yes, it has underfilled CD3015s.
So how is there missing pads under it? There's underfill. There's no corrosion that can corrode it.
No corrosion can corrode it. They decided to come off with the CD.
In the middle?
In weird places. There's completely random. There's no reason why they would pop off like that. You know, if the ground is melted to have the ground come off, all the rest should be hot enough to just come off. But no, they ripped the pads.
So that's bullshit.
And this is only the first of two that needs to be changed.
And what was it? Was it no charging or was it no USB?
No charging. CC1 shorted on one, and I haven't even tested the other one. Charger communication. So I'll go back to the ultrasonic cleaner, and then we can shape these up and green them. So one moment, please.
Set the intermission up. only 110 likes. That's not going to do. Until the likes go up, you're going to take a look at a picture of Tim Cook. The repair will continue when the people watching the stream hit the like button. Oh, you have Tim Cook with a funny looking laugh. How's that? You like that? You like that? Because that's all you're going to see. No board repair until the likes go up.
No, I don't like that. That's creepy looking.
What about scary looking Tim Cook?
It's conspiracy theory.
Angry
Tim
at
Cook.
you, Tim Cook. Tim Cook wants you to get the likes up. So where are we? 134. There's 189 viewing and 134 likes. Let's get the... We have an algorithm to fool here. We need to trick the algorithm into believing that people want to see board repairs. I need to trick the algorithm into thinking that people actually want to see board repairs. The Tim Cook will continue until the likes improve. Alright, almost there. Okay, intermission over.
Oh God, he left Tim Cook on my screen though. Okay, cover him with Apple schematics. Good. Okay, we're out of the ultrasonic cleaner. Still wet. Dry it off some. Okay, so they look pretty good. Clean off my tweezers real good to... I don't want any more flux on this, because the flux won't allow the solder, conformal coating to adhere well. I just have to clean my tweezers. First put them in the tip cleaner and then alcohol them. Okay, now we could just adjust these a little bit. This one needs to be a little bit flatter in here. Oops, alcohol. Let's get this, whatever this is, out of here. Okay, that's up against the board now. Okay, this one needs to be a little pointier. That looks good. This one looks fine. And this one we're going to form right now. So I have just a wire coming out of the middle of this. So I'm just going to form a curly Q right here. I'll cut it off there where I miscut it before. Let's get that little dangly piece off there. Oop, I got flux on the knife. I can't get that on there. Clean off the knife. Go. Just tuck that end in. Okay, now I'm going to take some conformal coating or solder mask, whatever you like to call it. Squeeze out a little bubble of it on the mat here next to me. I'll take my tweezers drop it in right like that. Let's make sure it gets all the way under and around it. There we go. Some on this one. This is the pad that loosened up on us. We're also going to put some around that. And then I'll take a near UV light. And hold this on this for a couple seconds and it'll cure it right up. That pad looks like it has a frowny face in it. So this UV curable solder mask needs to see UV light to cure. So I'm coming from the right side at it now, so now I'm going to flip the UV light over to the left side of it and do the curing all over again, just facing in the opposite direction, so that there's no shadows anywhere behind anything. Okay, then I'll use a Q-tip with some alcohol. Once we wipe it off, it won't be shiny anymore, and you'll be able to see it a lot better. Now I'm going to take the back of an X-Acto knife. I'm just going to scrape the top of this a little bit. Just to reveal copper in the wire. I'll dig out a little bit of the conformal coating, and we'll do that to all of them. Just the back of the knife, scrape. A little more cleanup. Now we need to wick all these pads flat. We have to be careful around our newly formed pads, and then we'll put some more conformal coating on it, on the connection points especially. So, some more flux. And wick, who stole the wick? There's a wick. And Lewis does not have a regular soldering iron. There it is. So let me disconnect this tweezers. I'm not using the tweezers. You don't want to wick with a micro pencil unless you have micro wick. Okay. Now, since I have these new pads here, I'm not going to try to rub across here. I'm just going to dab at everything, just straight down, straight up on everything. Just want to pull some of that solder out from underneath that. Oh no, I forgot one. Oops.
Oh, sweet mercy.
Paul Daniels with the all sweet mercy just scared the hell out of me while doing this. Thank you, Kim, though. But you scared the hell out of me. Okay, so we have some more work to do here still. Okay, back with the micro pencil. This needs some more solder on it. I'm going to try to be more careful as to not get solder on any of the other pads, because I don't want to have to wick again. There you go. Oh, damn it. I got solder on that one. Okay, so we're missing another pad here that I didn't notice. And that is a tiny amount of via to connect to. Let's see what this goes to. Oh, I'm off screen for you. Right there. So this one I need to do some counting. Okay, 1, 2, 3, 4, 5 down up against the side. So we go to the schematic and board view. Looking 1, 2, 3, 4, 5 down. Yep, that is going to be needed. There's no other points to connect to, so hopefully that via holds up. Yeah, that via should be okay. Oh man, this one's turning into a mess. Wouldn't it be the Paul cue if it wasn't a mess? Yeah, looks about good. Is this even cost effective, and how reliable will it be? So this is going to be 100% reliable. When we're all done with this sealed underneath the chip, you'll never have any issues with this. Cost effectiveness, this repair for this machine from us is $425. It's a flat rate. We do a flat rate here, no matter how complex the repair is, depending. There's some machines that are more expensive because the chips are hard to get, so we have to charge more because the chips are way more expensive than most. But on the whole, it doesn't matter how complex it is, it's always the same price per class of machine. So sometimes that bites you in the ass with a machine like this that I'm going to spend a lot of time on and a lot of effort on. And sometimes you make out on it when it's just one bad chip, one bad fuse, and you get your flat board repair fee for that. So it goes either way. Why is this acting like that? This board is liquid damaged. It's the original issue with this machine. This was liquid damage. Where did this little piece come from? Damn it. Why are you here? When working with stuff this small, gravity no longer affects anything. The surface tension is king with all this stuff. It's absolutely amazing the way things just don't behave how you think it will because there's no weight to it. Okay, that one looks good. This one looks okay. And that one still needs to be wicked. Let's get the solder off of that one corner pad. There you go, nice and flat. Okay, everything looks good here. I didn't miss any, right? So now I'm going to clean it off one more time. We're going to conformal coat it again. Make sure that the ends are sealed up nice. And then we will put a new chip on. So I will be right back. back. And we'll dry it off. Okay, one more round of conformal coating. Clean off my tweezers again.
Oh, sweet mercy.
I really gotta lower that volume. You mentioned you get the CD3215s from donor boards. No, the 15s we don't get from donor boards anymore. How often are the CDs bad? How much time does it waste when they are? With a job like this, if you put on a bad one, that would be bad. Because all of these jumpers and everything, once I put the new CD on, the jumpers are pretty much frozen in there. If I have to take the CD off again, these jumpers are probably going to be ruined. A couple of them might stay, but I bet you're going to have to redo a couple of them. So it would waste a lot of time if I had to do it on this. But we don't reclaim CD3215s anymore because CD3215s you could actually get on the market. The CD3217s have to be reclaimed, although I did recently see that they are starting to become available on the market, so we might not even have to do that anymore for any of the CDs. And how often are they bad? Well, you're reclaiming them off of a board that you probably know the history of, or at least you can surmise the history of by its physical condition. So if you see that the CD is liquid damaged or something like that, you just don't take it. Like what we have to do for the ISL 6240 and like SMCs and stuff like that. CD3217s we use maybe 4 to 6 a week we go through. CD3215s I go through a lot. In a week I probably go through maybe 6 to 8. They're not always bad. So what I'm doing now is I want to be absolutely certain that not one of the other balls is going to combine with anything that I fixed here. So I'll put extra conformal coating on connections between balls, anywhere where there's a possibility of it short-circuiting with something next to it. Oh no, I just noticed I pulled up my other pad. Damn it. I was overzealous with my Q-tipping and I pulled the curly Q ground pad out. Okay, that'll be fine. Okay, just a couple different angles with the UV. Make sure everything's adhered. I think we're ready to put a new CD on here. So, be back in a moment. I have to go over to store.rossmanngroup.com and pick up some CDs. I am back. Okay, we have our new CD3215 right here. So one thing I would like to check, what I was talking about before with leaving that ground pad out. So that's how it's going to go down here. Pin 1 is down here where the naturally missing pin is. So I'm just going to flip it straight up this way. And that means this row right here corresponds with this row right here in that order. So this one and this one this is the one that was missing. This is ground. And then everything here, this is also ground too. So if I buzz this out, if this one beeps to any one of these, then I would feel safe just leaving that ground one out. So multimeter on beeper. I don't know if that comes across on the microphone. So let's see here. This is the pin in question. This one right here. So I'm on that. Now if that beeps to this one, this one, this one. Okay, they're all ground. So I have conclusively proven that this pin is the same as all of these pins. They're all ground. So if I didn't want to, if I didn't want to put this curly Q in here and rebuild this pad, I didn't have to, because it's all ground. You don't need that much ground for any one of these chips. So since all of those are the same pin, I could leave that ground out. But don't ever assume that you can leave that ground out until you do a test like that. You have to test it. You have to prove to yourself that you can leave that ground out. Okay, I need to scrape a little bit. That one is not ready to get soldered to. That's good, that one's good. This one's okay. I don't completely like the look of it, but it will solder. That one's good. Okay. So now this is infinitely more difficult than just putting it on a regular landing pads. Because the new pads are a little taller. It might want to make it move in weird ways. You have to be aware of that when heating these back on. Is that a broken pad? What is that? Oh, I just noticed that. I want to know what's going on over here. That's a pad. That is a pad from underneath there that came off. That's one of the pads that came off. That's the underside of it. That should be adhered to the logic board. It got stuck to that coil. That's all. Okay. Okay. So now I'm going to start heating it while pushing some pressure onto the chip. You have to be careful with this. This is how I do all of mine, but this one's even a little bit harder. Put a little bit of pressure on here and get the flux warmed up and moved away. So as you heat up the flux, it'll all start coming out from underneath the chip. It'll get more or less viscous. It'll start flowing like water. And then then once it's flowing like this, you're sure the chip isn't going to float away or move anywhere on you because of the flux. And so now I could stop putting pressure on it. I still keep my tweezers there, but I'm not touching it. And there you go. I saw it move a little bit. I can make it dance. And there you go. The chip is on. You also verify that all of the components around, you saw them flash over back into solid solder. So that also confirms that everything should be melted. This, I don't know if I did it or not, but this capacitor's chipped, so I'm getting rid of that. I gotta get a donor board, and I'll put those back over there. But that can be for afterwards, because it doesn't need those to function, it just needs those to protect itself. So let's measure again. Let's put it on regular. Instead of the beeper, it's on the regular ohms. Measure here. 100K, that sounds normal. And measure here. 0.5 mega ohms. Okay, something seems off here. Why do I have 100K here? Oh no, okay. 600K. Okay, so that should be good. So, as long as it's cool to the... It's not cool to the touch, I'll use rapid cooling. Rapid cooling technology. Okay, it's cool. So now let's check this side. So we know we're still going to have issues on the other side, but let's see if this side is all working like it's supposed to again. So we have 5 volts. Yep, we're resetting. So that's not good. 5 volts. Nope, we're taking 150 milliamps. That's probably going right into this chip here. This is the one that's resetting.
Oh, sweet mercy.
Nope, something's wrong with what we did. Let's see. Do you have a dropper bottle? No. Is it going into this chip, or did I overheat the underside? All the work that we put on it, we may have overheated the underside, and this might be bad now. Yep, this one's bad now. Do you see the... you can't see that from all the way up there.
That side wasn't pretty when I got it 2 days ago.
So I put some alcohol on there, and you see it just melt away right away on that. So this side's bad too. We got to do this side. We're gonna wind up. I bet we're gonna wind up doing all 4 CD3215s on this.
Is there any pattern to the boards that have underfill versus the ones that don't?
No, they fail in the same. If it has underfill or if it doesn't have underfill, they fail at the same rate. The underfill doesn't help the CDs to not fail. It just makes it a lot more difficult to work on to change them. Because changing CDs is bing bam boom, you're done. It's so simple and quick and easy for us to do, but just because it has underfill, it complicates it so much more, and it makes it probably 5 times as hard. So yeah, this is gonna need more work than what this stream should be about. So, yep, this CD needs to get changed now. And one of the ones on this side needs to be changed. I don't know which one. We didn't determine that yet. Probably this one, because this looks like it was liquid damage to begin with.
That's not fair.
So this board has been through 2 repair streams, and now it's being taken off stream. It's going to go on my desk, and I'm going to just rip it to shreds and come out alive. No, not always. Not in my queue, anyway. I'm still annoyed with him that this thing has CPU MOSFET corrosion and it works just fine. That never happens for me. Never.
My favorite is when the SSDs, TPS 62180, and the CPU MOSFET are corroded, and I reflow it and it turns on.
That one was painful to watch.
I knew it was going to work, too. Could I have possibly screwed up something with the touch bar?
No.
That's messing with...
No, that's fine. No, I had to do so much work on this that I overheated this side. That's why it's not working. That's why this side went bad.
I'll take this offline so then we'll see.
Tell you what.
If you super chat $1,000 in the next 3 seconds.
Tell you what.
Paul,
I
will do it on stream.
I am going to take this other the side that's messed up now, the other side. I will take this off of here. And if even one pad comes off, oh yeah, look, there's solder blebbing on these couple of components. When you see these little solder balls form, that's the solder shrinking around the underfill shrinking around the melted solder, and it pushes it out in a little ball like that.
There were a bunch of those on the other side of the board before I even started working on it.
Okay, well then that's definitely bad. Whatever it was on, that's definitely bad. Because that forms little bridges and traces underneath the CD that just kill it. So if I pull this off and no pads come off the board, and I could just clean this up and put it back on, we'll continue and we'll do the other one. But if a single pad comes off with this, that's it. I'm taking it to my desk and I'm sitting relaxing for a minute, and I'll tear into this.
What is your strategy for taking it off without the pads coming off?
Exactly what I did. It should have worked just fine. So we'll do it again here. So right now we're going to start. First thing I do is I take my HAKKO Omnivice, which is affectionately known as the device of gravity. This thing is amazingly heavy for its tiny size. It's just a giant block of steel. I'm going to rest that on the board. That makes the board heavier and it won't move around as much because I'm going to be putting some force on things. So now I'm going to come in here with some hot air. So my hot air is just full and full, as it always is. I never change it for anything. And we're just going to heat this up. We're not going to heat it up to soldering. We don't want to solder anything yet. We just want to heat it up. And then I'm going to cut lines into the underfill. I'm going to take it away, especially when there's components next to it. All of this stuff in between the chip and the component I want gone. And this doesn't have any that's actually touching the components, so just lightly pull the underfill out from underneath the chip. I just want to break the bond a little bit. And this here, I want to get all of this out from between the two components. And then the rest just break the bond from the board. Okay. Now we're going to add a little bit of flux around the outside so that as it starts to get underneath there, as it starts to lift, it'll help flow all that solder that's underneath this. Then I'll take one of my tweezers. I'll get it underneath the corner of the chip. And now we'll start just soldering the chip. We're just going to come in and start melting the chip. Now, I can't see what the chip's going to do. The chip's not going to dance for me or anything because it's underfilled in there. But I'm going to pay attention to all the components around it. When all the components around it have turned shiny and I know they're melted, I'm going to see solder balls popping out from underneath this chip. And then it's ready to just lift up on it. There you go. Off.
Almost a Paul Daniels. That was almost the Oh Sweet Mercy. You saved yourself.
And it's soldered itself back on. I let it cool. So I don't want to pull another pad. So let's heat it up again. And there you go, gone. And that is how the first side should have worked. This should have came out just like that.
There's 0 ripped pads and there's almost an even amount of solder on each ball. That's good.
That's exactly how this should come off. So, okay, take two. Use take two. So now I'm going to switch my soldering iron again. I'll lift up my other one to turn off this one. And I'm just going to drop my tweezers right on my soldering iron steel, hold the tweezers, pull out. Now I'll use I have an old soldering iron tip that just doesn't take solder anymore, but it heats up well. We'll wait for this to heat up. You'll see the center of it glowing as it starts heating up too. And there you go, we're almost up to temperature. It's sleeping, but it heats up before, as soon as you connect it, it heats up to the temperature and then it goes to sleep. So now I'm going to hit the stand, we're going to wake it up. It's awake, so 840 degrees. And I need a little bit more flux.
Oh, and that gets rid of the under.
It helps flow it away. And now we're going to start just lightly scraping away at these pads, only in one direction. We don't want to push this way with our tip because we could get underneath the pad and rip it up. So we're just going to pull along like this and just get rid of all this underfill.
touching the underfill versus you're touching the pad?
You can feel the difference. The underfill, especially under the heat of the tip, starts feeling mushy. And then you can feel when you get down to the bottom. In the center here where it's thick, it's kind of difficult.
When I do this, it's very easy for me to rip pads up. I wind up plowing. But I didn't know what you just said about how you were going down. Makes you less likely to do that versus going up.
Yeah, if you start pushing up this way, because you're holding the tip like this, if you push up this way, you wind up ripping a pad up. This is not ideal. I hate getting these that have the underfill. I'd rather have them not underfilled. The underfill doesn't seem to save them at all. They still have the same amount of failures.
I'm curious if there's a solvent that would go through that, but any solvent that would go through that would probably also go through the board.
Probably. If the solvent's going to eat this stuff away, it's probably going to eat the solder mask away.
And also probably go through the amines and acids.
It'll eat your skin away too. So usually, yeah, that's one. Usually only 2 pads come off. You see that one that just started floating away? That's a non-connected. So there's 2 non-connected pads. There's one up here and there's one down here. Those usually disappear in this stage.
Does not connected go to ground, or does it just not go anywhere?
It just not go anywhere. So you just want to take your time with this step, because you don't want to have to do what we had to do last time and rebuild pads.
How do you keep your patience doing this?
Because I know what I have to do if I don't keep my patience. I know I have to build those little circles of wire, and I don't want to do that. So I will sit here and just be patient and gentle with everything.
Can you imagine if this chip was socketed like an IC3 is? You just click on the socket and it pops out.
That would be spectacular. That'd be a thing of beauty. I would weep with joy. But that would be impractical for something this small.
How big do you think a Macbook would be if every chip was the same?
What's that old black one with the tiny little trackpad? The 1182 or some shit like that.
You guys don't use soldering lugs, which we're building pads a lot easier. What's a solder?
I've never found one. You talking about like the Wiley pads? I haven't seen one that that is the right size for MacBook. They're all the size for iPhone. I haven't seen one that's a good size for MacBook. But I have used them before on some of the smaller chips, and they do work well.
Oh, sweet mercy.
That scares me every time.
Yeah, it's really loud. Micro janitor Paul.
Mop, mop, mop all day long.
It makes sense long term to build a machine for making wire circuits. No, long term it makes sense to never rip the pads.
Yes.
See, if you're building a machine to make wire circles, that means that you rip pads often enough that you're fucking something.
Now, if I ripped pads often enough, then I would probably have less hair than I do. And I already don't have enough hair. Oh no, I owe Sweet Mercy one resistor.
to see signs of a corroded sleep sensor.
Yes, that one pad does not look good up there at all. And this capacitor does not look good.
You make wire circles, I don't rip pads. We are not the same. You're not getting demoted, Rob Brown. You're gonna take that unpaid promotion with change in title with no change in pay and enjoy it. What is underfill made of? Underfill is made of...
Chemicals. It's probably some nasty caustic chemicals that you don't want to know about.
Underfill is made up of the hardened tiers of component level repair technicians.
Distilled tears.
Aged over several years. The pads and Apple products need to rip off more often than other PCBs. They're using budget resin. I mean, no, this is going to happen in any one of these boards. Really. When it comes to wick, Jessie says scraping is raping, and she does not like wick. She just puts solder over the balls that are already there, and then adds the chip on top of it.
And if you go to store.rossmanngroup.com and search for Jessa, you will find Gootwick.
She actually took a stream where I ripped the pad off, and she looped it on her stream and labeled the scraping as raping.
I love Jessa.
Top middle pad is ripped, but it's not connected, so it doesn't matter.
It was floating around here. I don't know where it went. It just popped off. They always do. There's two non-connected pads, and they almost always leave. The other one is still there. The other one's down over here somewhere, like exactly opposite of it, of one of these. Okay, so that one came off nice and easy and quick. And we'll be able to put the new one on nice and easy and quick. All the pads are wicked and flat.
I don't have a mic, James. I'm just yelling. I don't have another mic in the office.
Yeah, Lewis is just standing behind me. So sorry to all you headphone users that turn up your headphones to hear him and then you hear me speak. So just the right amount of flux. Oh, sorry, that was a little bit too much flux.
The large underfill chips like Wi-Fi use the same tracer. For Wi-Fi, you give up.
Wi-Fi is such a pain. The Wi-Fi chip is terrible.
Look at all this piracy that's being committed.
Okay, so again, I'm going to start pushing down on the chip just until the flux starts flowing. You don't want any solder to be melted when you're pushing down on it, or you just ruin the whole job. So the flux is now water-like, so I could stop pushing down on the chip. And you see it move into place. I'll make it dance a little bit. Once I see it's dancing fully all the way around, done. Let's get that weird solder ball out of there. Okay, I didn't move anything. Everything's good. Okay. So now we can super mega cool this one.
Now it's going to turn on and work. USB 2, USB 3, Thunderbolt, DisplayPort, charging.
On 3 of the CDs, yes. Can I touch it? Yes, it's cool enough. Okay. Plug it in. Here. 5 volts. 20 volts. 700 milliamps. Good. This one. 5 volts, 20 volts, 700 milliamps. Now we flip the charger. Oh, you didn't see that. So we unplug the charger, flip it over, plug it back in. Now we're checking the obverse of CC1 or CC2. Good. Check this one. Good. So that side is fine. So now we need to do one more CD on this side. So I forget which side we were looking at, so let's do our function check on this one again. Okay, I have absolutely nothing here. Flip over. I have absolutely nothing here, and this one should be fine. Yeah, that one's going to be fine both sides. We don't need to check that again. Okay.
How come you have 20 volts on all of the others, but one of them is dead? Usually when one of them is dead, nothing works at all.
It depends on which part of it is dead. So if CC1 or CC2 is dead, then you could have just the one bad. But if something that's like the 20 volt line on that is bad, or the 3v3 or 3v3 LDO is bad, that will take out the entire system. So we're working on this side. So now let's go back to the schematic and board view. I'll zoom out. So we are still right side up. I turned it this way, so let's turn our board view to match what we're looking at. And we are plugged in here, and it's the bottom part of this as we're looking at it. So here's CC2. Where does it go to? It goes to the one on the top of the board. So the same side as the connector is the one that we're working on. So now let's check CC1 and CC2. So they're right next to each other. We learned that from the last one. And we have the capacitors and diodes right there. Let's ohm check them.
Maybe that one won't be underfilled.
Wishful thinking. It won't be underfilled.
Why is it underfilled?
Okay, this is what we're looking at. So we're going to ohm check. CC1 is up here. That's this side of this one.
After all this, the touch bar doesn't work. That'd be very sad.
2 mega ohms is fine. And this should be the other one. 19 ohms. That's bad. So this CD is bad too. I'm not even going to bother trying to take off the capacitors and all that stuff. We just know it's the CD. Oh, and something I didn't go over at the beginning of all this is that I didn't bring them here, but the charge ports that were in this machine, that belonged to this machine, there were black pins on this. So that also helps you know that your CD's probably dead. Something that they plugged in, whether it be an accessory or their charging cable, something's bad. One of their accessories got destroyed with the liquid damage. And we know that that's bad already. Okay. Hopefully this one comes off just as easy. So again, we'll start with the device of gravity, right on top of the board. Hot air, full and full. And this one we have to be even more vigilant and more careful with how we heat it, because underneath this can that's right here is the SSD. So we can't overheat the SSD. Especially this customer, their data is important to them. Just about every customer, their data is important to them. Nobody backs up their systems anymore. If any of you own a laptop with an integrated SSD that's integrated to the board especially, please keep a backup. Don't ever trust your important data on that machine and that machine alone. Really, any portable device, even if you don't portable it, even if you don't take it out of your house. Don't ever trust your data in one place. Don't ever trust your data on one SSD. SSDs have almost zero paths to data recovery. They're fast, they're robust, they last a good long time, but when they go bad, they are bad. They're done. There's no getting your data off of that. Okay, so we ate all the way around it with our knife. Put a little bit of flux on it. I'm going to get my tweezers under this corner here where there's nothing that I could knock off. I'm just going to come right in and heat it up. I want to be quick about it here because I'm next to the SSD. Okay, I'm lifting now. And there we go. Time machine's a good thing to do. People always run out of iCloud. Not everything is on iCloud. I have a backup, yeah, Copaz. I have a backup to my laptop, tablet, and my desktop, and remote. Yeah, I have a Synology NAS at home, and I have just a mirror backup of my storage drive, my D drive. Every single change that happens to my D drive is reflected on the NAS in real time. And then the system gets backed up 3 times a week. Okay, now we'll take our... I still have my cutting blade on here. So, some more flux. And just nice and easy. Sorry guys, while I'm doing this, I cannot read chat. And Lewis left, so he's not reading chat. This a little bit more of the underfill for this one left on the chip, so that's a happy. So over here's that non-connected one. Let's see if we can get it to stay. Just lightly dab it, just get the underfill around it. Yep, we got it to stay. All right. Last little bit of stretch. There's a non-connected pad here too. Let's see if we can be gentle enough to keep the non-connected on the board. Let's clean off my iron. I thought it was for liquid protection. It doesn't seem to work very well. I don't think maybe one of the functions is liquid protection, but I don't think that's the primary function of underfill. I think it's more for shock resistance, vibration resistance. They didn't do underfill for very long, and they didn't do underfill on very many models, for the CDs anyway. That was a short-lived thing. I guess they did more studies and found out that they didn't really need it. But yeah, it's supposed to help liquid resistance, but there's external factors that are more important than it itself getting wet. The charge port getting wet and then plugging in your charger while everything is wet is more detrimental than just getting water underneath the chip. Like, it's the same if you had water underneath the chip and you plug it in versus you have water around the chip on the components and you plug it in. It's still going to kill it the same way. So I would think that this this thing's underfill is more for vibration. Okay, looks good. Okay, everything's flat. That looks good. Okay, one new chip. Here's our new chip. I have to get a wider set of tweezers to pick up this chip than my normal tweezers. So this one, since Apple doesn't do any silk screening on their board, so we can't tell where things are supposed to go and how they're supposed to align and everything. But this one, they kind of can't hide it on us because there's one missing ball on here. So there's one missing ball on the chip, one missing pad on the board. So just line that up instead of silk screening and having a white dot or a white line on the board here. They can't obfuscate this one. So I'll put some flux. Put the chip down in the flux, push down on it. Make sure it looks centered to start with. You already kind of have some lines to go by from when you cut away the underfill. And we're just going to try to line it up in the center. Try to push it around. It should stay in the pads because the pads are like little wells. The solder mask is actually kind of thick. And the pads are a little bit down farther than that by like probably 1/8 of a millimeter. But you can feel that by pushing it around. So a little bit of pressure on the top. Start heating. Once the flux gets watery and flows away, you know your chip isn't going to float away on the flux. So then you can stop pushing down. I keep my tweezers there just in case. You don't want it flipping up and going away. And it moved a little bit, and now I can make it dance. The whole thing's dancing. It's not hanging up on a corner. Yeah, I don't know how to show that. Maybe sometimes when I find something liquid damaged, I can show sometime that when you have corroded pads underneath a chip, and you reflow it, and you make it dance, and usually you see the whole chip all at once is going like that. Like as you move your hot air, the whole chip is going like that. But then if you have corrosion under one side and like really bad pins over here, you'll see that like this top is wiggling back and forth and it's trying to stay stationary here. Then you know that reflowing it isn't going to be good enough. You got to take the chip off and reball it. Okay, we will go with our rapid cool technology. Okay, that's nice and cool. So let's try this side. I forget which side was it we were working on. Well, that one works. I think it was that side. Oh, I keep putting it too far over. That one works. Now we're going to take out the charger, turn it upside down, plug it back in. That one works. And this one works. So that's all 4 ports, all 8 ways are working. So now the other issue that we were having, they said that they didn't have USB communication. So the first thing I'm going to do is, I can't do that on this. I want to make sure that the USB port is not putting out 20 volts, because there's faults that can be done in this, that this USB port will be putting out 20 volts, and it will kill anything that you plug into it. So, no, only 5 volts, good. It recognizes a USB device, and it gives it 5 volts, that's good. Okay, so we're going to plug this test OS into it. Now it's gonna try to boot into its own operating system, but on the way it's going to check the USB port and see if there's something connected to it. So what we should see here is that a blue light should turn on here and then start flashing. So that's the 2 key things we need to see, is a blue light, and then the blue light needs to start flashing. What sucks here is that we don't have any no, it wasn't even plugged in. A blue light, and the blue light starts flashing. So that means it's not only getting power, and it sees a USB 3.0 communication, but it is communicating. It's being read. If we saw green lights on here, then that means it's connected to at USB 2.0, and that would be bad. That would mean probably the JHL chip is bad underneath here, or something else is bad. So then we'll try this one. This is also something that you should flip it over and try too, but that's for later. We'll do that in the full testing afterwards. We have blue light, and then it should start flashing. Sometimes it doesn't flash unless you unplug it and plug it back in, but yeah, there you go. So it is communicating, it is reading. USB works just fine on 2 of the sides on that, anyway. Then we'll check over here. But first, same thing, I want to make sure that 20 volts isn't passing through. Nope, 5 volts, okay, we're good. So, plug the drive in, plug our charger in. Okay, flashing, that's good. Chances are, if it works in one direction, it will work in the other. That doesn't happen as often. It does happen, though. You can have USB 2 in one direction, USB 3 in the other direction. And that's usually the chip that's underneath here. That's the JHL something, 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 depending on board. I can't read it because of the bar. JHL 625, no, 627, no, I forget what it is. We can look it up. So that's this big dude, UB000. If we look that up on here, does this tell us? No. Keep going, no. I want to see the actual chip. Here's the actual chip. TBT control, it doesn't tell us what the chip is. No. I think we have them for sale on the website. Let's see. I have a snag? No. Do I have a screen capture? Where's it display capture? Browser? Wrong browser. Oh. Display cap? There we go. There's my smiling face on the website. I look very young, Lewis. So let's see. I want JHL. I don't know what the rest of it is. We do have them. So JHL 6540 or 7540. So I don't know. Yeah, it's hit or miss on which ones they are. 170, and they're more than this. We just added these to the website, and more information will be coming on them soon on here because it's not only U2800. There's one on each side. There's one JHL chip handles 2 Thunderbolt ports. So we'll have more information eventually on the website for these. But yeah, that's usually the problem if you have USB 2 and not USB 3, or USB 2 on one direction and not on the other direction. Okay, so the main focus of all of this was a bad touch bar connector. All the rest is just collateral damage along the way. So what I'm going to do is get my test housing like last time, and we will plug in to that and see if this is working now. So I'll be right back. Turn this off. Okay, so we have a 1706 test housing that I'm sure everything works in. So I'll just take this, put it in here.
Touch bar?
Hopefully.
The one thing left to not work on this is the thing that I worked on.
So I'm going to connect the power button because I might need the power button.
Should we tell Wasim what piece of software is being used for the schematic? Flex Board View.
Flex Board View from P.L. Daniels, Paul Daniels, pldaniels.com.
I should cross out the name of the software on the screen. Like, you know all those television shows and movies where they cross out the name unless you pay them?
Okay, touch bar's plugged in. I got some charge ports plugged in. I got my screen, keyboard, and trackpad. That's all I really need. So I have a test OS. I have a charger. I don't have the battery plugged in. So the machine does not need a battery to turn on. I'm going to hold down Option to bring up the boot menu.
Really, really slow without a battery, or is that just all there?
No, this one should boot fast enough.
Please work. Bar of touch, bar of touch.
load into an old OS of High Sierra.
I'm going to mute for It's obvious.
Yeah.
Right. Steve trolls me with that. Touch bar.
Hey, touch bar.
Whoa! Oh, only half of it is there.
That's all that's available. It's not responding to touch, though.
Oh. What if you log in? Maybe it'll respond to touch when you log in.
No, it should be working by now. Nobody look at my password.
Is that the customer's touch bar?
No. This is my
Test housing?
my test housing.
Oh. Well, I can't blame the customers.
So we might have to look at that connector one more time.
Yeah, touch bar, see?
Yeah, no touch. We have our display, but no touch on the touch bar. So we'll do a little bit more investigation.
I definitely screwed up the connector.
But we're halfway there. We have USB communication. We just boot it on our USB drive. So we'll take a look more at this connector. There was 2 pins that looked like they needed some more solder, so. But it's time for me to pack up and get out of here for the night. Good hanging out with all you guys. Glad you stuck around for this repair. Hope you learned something on it, as Lewis always says. And happy MacBook repairing for any of you guys that actually do this. Have a good night, everybody.